From here, it is possible to post-multiply both sides by the, which way do I want to do this? Wait a second. I'm trying to solve for this, right? So we can say that phi, not j, because these are all of them. No. My apologies, sorry. We don't want to solve for this one, we want to solve for this guy, which is the derivative of the lefts. So we have that the derivative of the left transpose is equal to minus the left transpose, all of them, times all the derivatives of the right, times the inverse of the right, okay? And sorry I got into this the roundabout way. When I did it in class, I already set it up from the beginning with all of them, but I don't know. When I was doing it here, I started looking at J. So we have this, right? Now, we can make it more elegant by recognizing that the inverse, so this is the derivatives of all the lefts, is equal to the lefts transpose, the matrix that lists all the derivatives of the right, and the inverse of the rights are the lefts transpose, right? So we get this. Now this is the derivatives of the left transpose, so if we transposed, we can say that the derivatives of the left side eigenvectors is equal to the negative of. Transposing requires changing the order, so we get phi left the transpose of the derivatives of the right and phi left. And so we finished because we now have everything. This is the expressions for the left side derivatives, and we had the expression already for the right side derivatives and for the eigenvalues. There is something very important to recognize here conceptually, and it tells you that although you can calculate the derivative of the right side eigenvector one at a time, you cannot do the same for the left side eigenvectors. You have to get them all at once because they depend not on one of these but on all of them because of the normalization issue. Okay? Now, in the class next time, I will be beginning by showing you some numerical examples on these things and so on. This topic, by the way, that is eigenvalues and eigenvector derivatives, is a possible topic. It's not really identification per se, but is a topic that has sufficient interest to actually consider it as one of the possibilities for your for the paper that you might want to write at the end as your presentation. We have done here a number of things, some of them that are you would not find in the literatures, at least I'm not aware of anything like this. And you can expand on these things with some studying and looking around in the literature to see what happens in the case of some repeated eigenvalues. Okay? Anyway, I'm not suggesting that anybody pick it up. I'm just saying if you were interested on this kind of topic, this one would be a valid one. Okay, so I am now concluding for the day, and we'll be uploading this shortly.